Now let us see the data types available in Java. Now there are different categories under which the data types are classified. Now the first of them is the Boolean, and under the Boolean we have a single data type which is Boolean. Now Boolean can have only two values, either it can be true or it can be false. So any other value if declared for a Boolean cannot be taken for a Boolean and will generate an error. Now first of all we must remember that Java is strongly typed. Now strongly typed means that error checking is strong. Secondly, it is statically typed, means the variable must be declared first before it can be used. So now how to declare a Boolean variable is, we will say Boolean, any name of the variable, say a is equal to true, or we can say equal to false. So any other value, if we say a equal to 3, will not be taken for a Boolean. So for Boolean only two values can suffice, either true or false. So next in line we have the integer data types. Now under the integer data types we have four types available. The smallest is the byte. Now depending upon the size we have categorized them into four types. The smallest is the byte. Now byte is 8 bits. Now as we have seen in the last lecture that every variable in Java is signed. So all variables are signed. I will just put down here. All variables are signed. So for a 8-bit byte the range will be minus 2 to power 7 to 2 to power 7 minus 1. So as we had seen, the 7 comes because only 7 bits are contributing to the value and the 8th bit is reserved for sign. Now how do we declare a byte variable is byte a is equal to suppose 1 0 1. So this is how we declare a byte variable. So similarly we have short. Now this is 16 bits and accordingly the size of the variable ranges from minus 2 to power 15 to 2 to power 15 minus 1. So again how to declare a short variable is short, the name of the variable, say a, and any value. So these are two variable types we have in Java. Next in line is the, take a new, next we have the int. So int, we have this is 32-bit and the range again goes from minus 2 to power 31 to 2 to power 31 minus 1. Now default for the integer data types is the int. And how to declare an int variable will be int k is equal to 4444. This is how to declare a int variable. And next we have the long data type. Now long data type, this is 64 bits and the range of value lies from minus 2 to power 63 to 2 to power 63 minus 1. So this is the range of the long variable, and to declare a long variable we have long, the data variable name and the value, and then we append an L to the value. Now, in case we do not append an L, this becomes an integer value. So this we call as a literal. So this is an int literal. And in case we do not append a L here, so this now becomes an int literal, and an int literal can be assigned to a long variable. So the range will however be restricted by the range of the int. and as soon as you append an L to this, this becomes a long literal, and the memory now allocated goes from 32 to 64 bits. So this is an important point to remember, that whenever we write a long literal, do not forget the L. So we can just see this difference also. And second point worth remembering is that any calculation that we perform is performed on a minimum int scale. So this is a very important point to remember. We make very slight mistakes regarding this, as I'll just show you a basic mistake on this. Now, first of all, we can see a just declaration of a long variable. I say long is equal to so as of now it is within the range of the int, so there is no error, and as soon as we cross the range of the int, it immediately generates an error which says that this literal is out of range. This literal of type int. As you can see, this literal of type int. So even though the variable is of type long, the literal is of type int, and as soon as I append an L to this, immediately the literal becomes long and the error goes. So this is how important this L is to append to this value. So this, without this L, the number is represented on a 32-bit scale, and with this L, the number goes on a 64-bit scale. So this is the first important point worth remembering for the data types. And second point, as I have said, that the calculation on computer can only be performed on a minimum int scale. Now we can see a very simple example of this is if I say byte b is equal to plus a. So I've just appended a plus to a variable. So this is some sort of an operator to a variable, not affecting the value. Still the system is not able to operate on this. It wants the b to be on a int scale. As soon as I make it int, the error goes. To make it more elaborate, we will have two variables and say byte c is equal to a plus b. Now immediately there is an error. Even though a and b are both within byte range, the sum is within the byte range, yet the sum cannot be stored in a byte scale. This is because a and b are both promoted to int. A goes to int. Now in this calculation, a automatically promoted to int, b automatically promoted to int. The sum becomes int but cannot be stored in a byte. So this is where the error comes, because storing an int in a byte means we have to decrease the size and we might incur some data loss. So it cannot be stored. Either we make this as an int, or we'll have to downcast the result, as we will see during the tutorial on casting of variables. So this is what is more important to remember, is that every calculation is performed on a minimum int scale. Byte calculations cannot be performed. So for every calculation, the result will be minimum int. So we must keep this in mind while trying to store the result of any calculation. Then we have on the floating point side, we have two data types. One is float, which is 32-bit and is single precision. And how do we declare a float? We say float a is equal to 3.2 and an f. So we need an f with the value to make this as a float literal. And for a double, this is 64-bit and double precision. So to declare a double, we write the double value 32.22. So this is the default for the floating point. So these are the data primitive data types that we use in Java, and next we'll take up the char data type.